In 2029, NASA is set to unveil one of the most ambitious advancements in aviation technology, the X-59, a supersonic aircraft that promises to redefine the way we think about air travel. Unlike traditional supersonic jets that generate the notorious sonic boom when they break the sound barrier, the X-59 is designed to eliminate this disruptive phenomenon entirely. This aircraft is not just another leap forward in speed, but a transformative shift that could open the door to a new era of high-speed, long-distance travel that's quieter, more efficient, and potentially more accessible than anything we've seen before. The X-59 is the result of years of research under NASA's Quiet Supersonic Technology (KSST) program, a groundbreaking initiative aimed at overcoming the challenges that have historically made supersonic flight unfeasible for commercial aviation. For decades, the concept of commercial supersonic flight has been limited by one major drawback: the sonic boom. The sonic boom occurs when an aircraft exceeds the speed of sound, creating a massive shockwave that generates a loud, thunderous sound as it travels to the ground. This noise is so intense that it can be heard for miles and can even cause structural damage to buildings and other structures. Because of this, supersonic flight has been banned over land in many parts of the world. The only civilian supersonic airliner ever to operate commercially, the Concorde, was retired in 2003, partly due to noise concerns and its high operating costs. Although supersonic aircraft have the potential to drastically cut flight times, especially on long-distance international routes, they've been largely restricted to military and private uses. Enter the X-59. The aircraft's primary objective is to eliminate the disruptive sonic boom, or at least mitigate it to a level that's barely perceptible from the ground. NASA's engineers and aerospace experts have spent years developing a novel design that uses advanced aerodynamics to minimize the shockwaves generated by the aircraft as it moves through the air. Rather than having the blunt, sharp nose typical of conventional supersonic aircraft, the X-59 features an elongated, slender fuselage with a sharply pointed nose. This design helps to spread out the shockwaves, preventing them from combining into a single, loud boom. Instead, the X-59 produces a quieter thump, a low-impact sound that, when heard on the ground, would be no louder than the sound of a car door closing or a distant thunderclap. This is a monumental leap forward in aerospace engineering, allowing supersonic flight to become a reality in civilian airspace without the noise pollution that has historically held it back. The implications of this technology are profound, especially for the future of commercial aviation. Imagine flying from New York to London in just a few hours, instead of the typical 7-hour journey. Long-haul flights between major cities could be reduced by half, making international travel far quicker and more efficient. Business travelers, for example, could travel across the world in a fraction of the time, attending meetings in the morning in one city and returning home in the evening without the long layovers or overnight flights that are currently the norm. Similarly, cargo transport could become faster, improving global supply chains and reducing shipping times for perishable goods, pharmaceuticals, and other time-sensitive materials. By significantly reducing flight times, the X-59 could also contribute to environmental sustainability, as less time in the air could translate to reduced fuel consumption and lower overall emissions. The X-59's potential for noise reduction is especially important for addressing the concerns of people who live near airports, where the noise from aircraft can be a constant disturbance. The aircraft's quieter design could allow supersonic flights to operate over land, where noise from conventional supersonic jets would have previously made them untenable. This means that supersonic aircraft could operate between major cities without causing significant disruption to communities. In fact, one of the key elements of NASA's testing for the X-59 is to gauge how the low boom sound is perceived by people living along flight paths. NASA plans to conduct test flights in the coming years, carefully analyzing how the thump produced by the X-59 is heard on the ground. If successful, the X-59 could lead to a paradigm shift in the way commercial air traffic is managed, with supersonic flight becoming as routine as conventional air travel. In addition to transforming commercial air travel, the X-59's design has the potential to revolutionize aviation in general, including the development of hypersonic aircraft for space travel. Supersonic flight is often seen as a precursor to faster-than-sound travel in space, and the technologies developed for the X-59 could be used to design spacecraft capable of reaching orbit more quickly or entering and exiting Earth's atmosphere more efficiently. As humanity looks to explore deeper into space, with missions planned to the Moon, Mars, and beyond, the ability to fly at supersonic and hypersonic speeds could significantly reduce travel times and increase the effectiveness of space missions. The quiet supersonic technologies pioneered by the X-59 could even be adapted to reduce the noise and environmental impact of space launches, which currently generate significant sound pollution in the vicinity of launch sites. Furthermore, by pushing the boundaries of speed and efficiency, the X-59 could contribute to the development of new aerospace technologies that will play a crucial role in the exploration of our solar system and beyond. Despite its potential, the X-59 is still undergoing a series of test flights and evaluations. NASA has been working closely with Lockheed Martin to develop and refine the aircraft, and the first flights are expected to take place in the near future. The aircraft will undergo rigorous testing to measure its speed, performance, fuel efficiency, and, most critically, its noise levels. The success of the X-59 is dependent on gathering data from these tests to refine the aircraft's design and ensure that it meets the stringent standards required for commercial supersonic flight. If successful, the X-59 could pave the way for a new generation of supersonic airliners, reshaping the way people travel and changing the future of aviation forever. As the testing continues, scientists and engineers remain hopeful that the X-59 will become the first step in ushering in a new era of air travel. One that is faster, quieter, and more efficient than anything we've seen before. With the X-59, NASA isn't just advancing aviation technology. It's setting the stage for a future where the boundaries of speed and distance are no longer limiting factors in our ability to connect the world. The aircraft symbolizes a bold leap forward in human ingenuity and technological progress, opening the door for a new era of high-speed, low-boom travel that could change the way we experience flight for generations to come. Whether for business, leisure, or space exploration, the X-59 could ultimately help make the world feel smaller, bringing people and cultures closer together while pushing the limits of